Here we go. Now we have sound too. Excellent. Well, welcome. I will be talking about openSUSE in the public cloud. Cloud what? What's that thing? Produces rain, right? Ugly, gray stuff. Anyway, so let's see. This is what we'll be talking about. Something about me, just for fun. Why not? What is it and why you might want it? Where do we stand today with openSUSE and the cloud stuff? Well, public cloud stuff, so there's a difference between what these guys do and what I do. How things are put together, so we'll take a look at, what do we do to get there, and then how it works, and if you have questions, then I will be more than happy to answer them when we come to the end. But if you have questions in between, please feel free to interrupt me, and I will try to answer them as good as I can. All right, something about me. I work at SUSE in the ISV engineering team. What is the ISV engineering team? ISV stands for Independent Software Vendor. So I work with people that are generally outside of the open source community, proprietary applications and things like that. And but that has become a lot less of my job since I started taking over the public cloud initiative. And public cloud basically means anywhere where you see SUSE Linux Enterprise in the public cloud, that means Amazon, Google, and so on, I had my fingers in it. I am also the IBM software group liaison. That means I work closely with IBM. If they have questions, they come and ask me, and I help them along the way with SUSE Linux questions. And integrated systems are basically things that we put together with ISVs, where they create an appliance, which means the application is already part of the image that you might get, and then you can just install it in your virtual infrastructure. So those are the things I work on during dollar day job. I also contribute to Kiwi. Kiwi is an image builder that is the back end of SUSE Studio. And I have a workshop tomorrow, on Monday, about how to build images with Kiwi. What do I do for openSUSE? I maintain packages. I am a board member and generally opinionated about pretty much any discussion that goes on most openSUSE mailing lists. So I have my fingers in all of the sockets. And I'm very passionate about motorcycling and soccer. And every chance I get, when the weather is nice, you will not reach me because then I will be sitting on my motorcycle riding around the world. Okay, so what is it? This is what I decided it is. Because I came to the conclusion that I can just as well decide what the public cloud is like everybody else that makes up their own stuff. And so I decided I can make up my own statement, and here it is, okay? A public cloud provides access to computing resources, yay, that is available to everybody through some kind of interface. Usually that's a web application. So Amazon.com has a web application to access their public cloud, as does Google, as does HP, as does Microsoft, and many other providers. Okay? So the key here is public. Everybody can use it. You get an account there, you give them your credit card number, and then you're on the public cloud train. Okay? The frameworks are different, which means not just the web application that you see, but also the underlying technology is very different from one cloud provider to the next. For us, that means we have to deal with the differences in the underlying technology behind the web interface, okay? That means openSUSE has to have different images, and these images get built with Kiwi, okay? Some keywords, when I say VM, that's a virtual machine. When the VM is actually running, we talk about it being an instance. And what else? Instances are deployed from images, okay? So what's next? So what is it? Well, there you go. We are all connected to the cloud, whether you think you're using it or then, well, you are using it, okay? You have a Gmail account, you're using the cloud. All your mail, everything is stored in the Google Cloud, okay? Almost everything these days runs through some kind of cloud framework. Your phone calls, yes. Google searches, obviously, right? You go to Amazon and you want to buy something, that runs in the cloud. Amazon's web shop, where you buy stuff, runs on Amazon Web Services, which is their cloud implementation, okay? So Amazon is a customer of itself by using the Amazon public cloud to run their store, basically. And so we are all connected to the cloud in some way, shape, or form. Maybe your pictures in Flickr or whatever else. SlideShare, anybody? Yes, cloud, okay? So everything is running on some kind of framework these days. So what might you want to do with it, or why you might want it? Okay, so if you're building code, using the cloud, if you can't build fast enough on your local machine, or you need to run some tests, you can do that in the cloud. It's generally pretty cheap, okay? If you want to test something and you say, well, I don't want to mess with my local machine, and for example, if you don't have Btrfs with Snapper and you're afraid that you might mess up your root file system, right? Fire up an instance in the cloud and install away, and then if it breaks, then, well, nothing happened. You just delete it, it costs you a couple of pennies, and you're done, okay? You can also host a service. So there are a lot of startup companies and established companies that use public clouds to, host their services, host their product. Netflix, for example, provides all their videos through the cloud, and they're a huge customer of Amazon. So all of Netflix's infrastructure runs on Amazon. Netflix themselves own very little hardware compared to the hardware that they would need if they would host the service themselves, okay? You can also use the public cloud to become an expert and get a job, because cloud is all the rage, and so, if you become an expert there, I am sure there is a job out there for you, if you're looking. You can also use the cloud to just store your backup data. So you can shovel all your stuff that you have on your machine. If you want to back it up, you can all shovel it into the cloud. The cost there is basically the storage you have to pay for and the network traffic to get your stuff in there. Of course, that requires a relatively fast internet connection. So those are some of the things you might want to do with it. Okay, so who's out there and what are we doing? So the elephant in the room is Amazon. Amazon Web Services, or AWS, with EC2, which stands for Elastic Compute Cloud, is the largest provider of public cloud today. And I predict that they will remain the largest provider for public cloud services for quite some time to come. My estimate is that they probably have 70 to 80% of the market. Primarily because they were the prime mover, so they were really the first guys to do this. Since they started, they consistently have lowered their prices, so it's becoming cheaper and cheaper to get started and get going. In the time for the other guys to start, they've accumulated a lot of services. So Amazon doesn't just provide images, they also provide services such as a database, query, and all kinds of functionality that the other guys need to catch up with, okay? So as far as functionality is concerned, what is available in the cloud, Amazon is ahead of pretty much everybody else. They started earlier, so they're ahead. Google just entered this market, although Google obviously had their own cloud for, many, many years, storing Gmail, pictures, Blogger, you name it. As a public cloud provider, they're really young. They started last year, in the fall was the announcement. They've been growing pretty fast. There are now 3 regions for Google, 1 in the US, 1 in Europe, and 1 in Asia. Amazon currently has 8 regions, 2 in the US, Europe, 3 in Asia. There's Japan and Singapore and Australia. 1 in South America, so they have data centers all around the world, and each one of those data centers is basically a region, and each region is 1 cloud instance, okay? And then there's Microsoft with Windows Azure. That's also cloud. This is quite different from everybody else, but this is where we are today. So openSUSE, if you have an account in any one of these 3, you can start an openSUSE instance in these 3 clouds, okay? There are other clouds that we're working on, but that are not there yet. Yeah, so the openSUSE instances that are there currently is openSUSE 13.1. Most of them have just been uploaded recently, and they just work, and it's wonderful. Okay. So where do we stand with the images? So the images come from the openSUSE build service, of course, and they get built in the Cloud Images project. Okay, so if you go to the openSUSE build service, build.opensuse.org, you can look for the Cloud Images project, and you can see how this works by just looking at the names of the images. Okay, so these things that are called packages here, I'm going to use this toy. Haha! So you can see here we have an Azure guest, we have an EC2 guest, we have a Google Compute Engine, GCE guest, and there is no longer an HP and an OpenStack guest because the HP cloud is actually based on OpenStack. So just a couple of days before I got here, I merged these 2 together, the HP guest and the OpenStack guest, and while I did that, I probably broke something. So the OpenStack stuff needs to be tested a little bit, hint, hint. And then I need to get some reports on that, whether it works or not. So basically, this is where the images come from. What happens then? I download them, and then to my machine, and then I log into my accounts in the various clouds, and then I upload them. And my accounts in this case means a SUSE account. So SUSE has accounts in all of these cloud providers, simply for the reason because we make SUSE Linux Enterprise available, and from an openSUSE perspective, we get to piggyback on those accounts. So making the images available in the public cloud doesn't actually cost the project any money because we can piggyback on the infrastructure that we have and the agreements that SUSE has with these cloud providers, okay? So generally, if you, and so this is also somewhat of a, of a crux, is when you do something in the public cloud, it costs money, period. Not necessarily a whole lot, but it costs money. And so while anybody in this room or anybody in the community can take either these images that I have set up or can set up their own images and they can upload them to the public cloud and they can publish them as openSUSE images, they'll just be as official as the ones that I'm building. So, I'm not putting up any hat and saying, ooh, I do the official images, certainly not. Anybody can do it. The thing is that whoever does it, they have to pay money, right? Because they have to have an account with the cloud provider and you have to store the image. Even if the image is public, you storing it, you're paying for it, okay? The advantage of me doing this is that I have access to the SUSE accounts and therefore the storage and stuff doesn't cost me personally or the project any money. So if we go and dig in a little bit, for example, in the Google image, and you can see here, it built it successfully. Hooray, that's what we like to see, green stuff. Oh, and the green pointer, wonderful. You can see that this is basically a Kiwi setup, Again, the images are built with Kiwi, okay? And so we have a configuration file, that's a script that gets run by Kiwi, an images file, and again, for all these details, you want to come to my workshop. And then this file with the .kiwi ending describes the packages that go into the image that we're building, okay? And basically, the images that we're building are minimal images, so there's not a whole lot of stuff in there. If you want to run a web server, then you fire this thing up, and then you need to run zipper in Apache or whatever web server you want to run, okay? What's nice about Google, so at this point, Google actually is also hosting openSUSE mirrors. So when you update an instance that you're running in Google, you're getting really good bandwidth because the mirror is right in the same data center, and it doesn't cost you anything, okay? Because the network traffic is within the data center, so they don't charge. I'm still working with Amazon to hopefully also be able to provide the same service in Amazon, where we can set up openSUSE mirrors in each of the Amazon regions, and then you would basically get the same service, okay? But currently, we only have mirrors running in Google Compute Engine. Okay, so how is this stuff put together? You just saw here the Kiwi configuration, okay? And Kiwi is fully integrated into OBS, which is the build service, of course. The Kiwi file contains the packages that we need and the repositories where to pull from. Config.sh makes generic settings. For example, in Google, it sets up an NTP client to point to the Google NTP server that runs within their cloud to make sure that the time is what they expect and is accurate, okay? And there's other settings that happens. And then the root tarball that you saw, that's an overlay tree that puts in certain files into the image. In this case, it's pretty empty. It considers the network configuration, so it sets up Ether0 as DHCP, and it puts in the license files, okay, which is basically what we need. But the rest of the image is very basic. Okay, how it works from the image point of view, okay? As I mentioned, I use accounts connected to SUSE, and therefore there is no cost to the project. We take the image from OBS, upload the image. Once the image is uploaded, I fire it up, make sure that it boots, that I can log in with SSH, and then I run zipper in or zipper up just to make sure that the repos are there. Okay, and that's all the testing I do. Once that works, I'm happy, and then I push the publish button, and then they're available in, whatever form the various cloud providers make them available. Okay, so if you want to use the wonderful things that we do from OBS, then you need an account with the cloud provider. Amazon has a sign-up, obviously. Everybody has a sign-up. If you already have a Gmail account, then you're known to Google. All you need to do there is then activate the Google Compute Engine service, which means you have to hand Google your credit card, which they might already have anyway. So, you're not revealing many secrets to Google. And of course, Amazon wants your credit card, and so would Microsoft and everybody else. So from that point of view, they're all the same. Then you launch an instance from the whatever cloud service you're using from their web console. Okay, so it's a web UI, and we should have plenty of time, so I can show you at least the Amazon UI and maybe the Google one. And then once it's launched, then you can log in via SSH, okay? There's no GUI, it's just a remote shell, basically. Obviously, you can get a remote GUI if you want. You can install an X server in the thing, and then you can, do SSH-X, and you can get remote display if you want a GUI. But if you really want a GUI, then the cloud is not necessarily something that is for you, right? It's really primarily command line driven, okay? The command line tools for these to interact with the clouds are also in the build service, okay? We have tools for Amazon and for Google. For Amazon, that's called AWS CLI, that's the package. It provides command line tools to interact with the cloud, okay? So you don't actually need to log in with the web browser and point and click if you don't want to. You can launch instances, you can shut them down, you can attach disks, you can do all kinds of stuff all through these command line tools, okay? And so there's a project, AWS CLI, that is actually in GitHub. That's also supported by Amazon, and so they work completely in the open. That code base is based on Python Bodo, or Python Bodo Core, which provides the basic web requests to the Amazon interface, okay? So all you need to use those tools is once you have your account, you have an access key and a secret access key, and then you can configure the tools to use that access key and a secret access key, and you can interact with the cloud without ever touching your web browser. Very similar for Google. Their tools are part of what is called the Google SDK. There are currently two commands that you would use, which is gsutil and gcutil. gsutil is to access their storage backend, and gcutil is to access their computing backend. Eventually, or Google is working on integrating them all nicely like Amazon did. Unfortunately, that work is not happening in public, so you can't contribute to that, but the code is open source and will eventually end up on GitHub at some point. You find the packages, they've been all submitted to openSUSE Factory, so 13.2 will have the packages by default. For 13.1, you need to add the Cloud Tools project to your repositories in openSUSE. Oops. All right, Amazon. Okay, as I mentioned, currently the elephant in the room, the biggest cloud provider. AWS CLI package, and this is how you use it, okay? It's AWS, and then as a command, which is EC2, if you want to interact with the cloud, okay, with their Elastic Compute Cloud. So AWS integrates all of their tools. So they also have other things like storage, cloud formations, which means you can describe how certain things are supposed to interact. And then they have different commands for that. Anybody heard of Mechanical Turk? Yes, so there's a command line for Mechanical Turk, and that's also integrated in AWS, okay? So you can say AWS Mechanical Turk and then something. So if you're playing around with Mechanical Turk, you can do that from the command line and you don't have to sit there and click. Of course, if you're evaluating pictures, you still have to see them, right? Anyway, so this is how you use it. AWS, EC2, subcommand, that could be run instance, for example, and then you give it the image that you want to launch, and then off it goes. Okay, so there are 8 regions, and as I mentioned, there are no openSUSE mirrors in Amazon at this point. But if we can come to agreement with Amazon, then I will be more than happy to set up the mirrors, and I will then kindly encourage our openSUSE.org sysadmin team to watch over them once I have them set up. And I know that Darix is very happy about that. So, Google. Okay, as I mentioned, Google is the newest entry into the public cloud market, which came just in, well, actually almost winter last year. You want to install the Google Cloud SDK. The commands are gcutil and gsutil, not fully integrated, okay? And we currently have 3 regions. And here we have the openSUSE mirrors. I don't have a mirror in Asia yet, but hopefully next week when I'm back home, I will be able to set that up. So, Azure. Yeah, what can I say about Azure? Unfortunately, Microsoft decided to write the command line tools in JavaScript. Ooh. So yes, Node.js. And Node.js is, well, let's put it this way. We basically currently have no infrastructure of reasonably packaging Node.js scripts in any shape or form. The good news is that Fedora has all that stuff. And over the next month or so, I will do my best to basically copy what they've done and bring it over to openSUSE, and then I can start copying or building packages for the Azure CLI, including the 120 dependencies that they have. So yeah, JavaScript. And, and I thought Ruby was bad, but whatever. But if you are really interested, you can install the Azure CLI from the Node.js packaging system, which is NPM. And you can just run npm install, I think it's called Azure-CLI, and that will actually work. But there will not be any packages, for a while. The regions in Azure are a bit different than the others, and it's really difficult to compare, and so I'm not really even going to go in there. And there are also no openSUSE mirrors in Azure, and I haven't really had the chance to talk to Microsoft whether they would be amenable to hosting these mirrors or not. Okay, and now it says Amazon demo, okay, and so I'm going to try and do that. But before I go there, let's go here and see if there are any questions so far. No, okay, good. Then, all right, now I'm stuck with a GNOME desktop. Right. Turn this off. And a German keyboard, oh! Yeah, that didn't work, did it? Ha! A German keyboard with a US mapping, that'll be fun, people. All right.
Take the microphone.
I will. I'm working on it. I'm working on it. Go easy with me. Like a piano player. Look at that. Okay, so what you see in front of you now is Amazon Web Services, Amazon.com. What? Oh, how do I do that now? Good luck. GNOME, thank you. Oops, where did it go now? What? Is it up? Down? Oh, now it went away. Here it is. Okay. Now I can't move it. Oh, now maybe here. No? Up? Left? Right? Hi. Okay. So, of course now I can't see, but Hey, how bad can it be? And now what do they do? Oh, they don't do buttons for large windows. Huh, look at that. Make that bigger. And, no? No, not bigger. Okay. Maybe I should sit on the other side of the desk now. Now you get to see the back of me. You don't have to look at my face. See, look at that. All right, so this is where we are. So this is aws.amazon.com. And what happened to the mouse? Also on the other screen? Right? There it is. Hooray. Thank you. Okay, so you can see a sign up button here, obviously. So if you wouldn't have an account, you would go there. I do happen to have an account, so I go right there. And, yep. And then we go here. What did we say? It was a US keyboard with, no. A German, no, a Croatian keyboard with US mapping. That means I should be here. Yay! Okay. Now I have to remember that. Let's see if that works. No, certainly don't remember that. Okay, and so now you see all the services that Amazon offers, okay? So there's database stuff, Dynamo, database, Elastic Cache, all kinds of stuff. CloudFormation, that's a tool where you can orchestrate various virtual machines to work together. For example, okay, then there's application which goes into the platform as a service direction and so on. So these are all the services that Amazon offers. Then there's, for example, just storage. S3 is an object storage backend. And when you have Amazon images, they can be either S3 based, which is this simple storage, or EBS. EBS is called Elastic Box Storage, and EBS is actually persistent. So as long as you don't delete the instance that you're running, but you just stop it, any changes that you make will be persistent the next time you boot it up. If you terminate the instance, then those changes go away, okay? By default, but you can change that when you launch the instance, okay? So what I wanted to show is EC2, which stands for Elastic Compute Cloud. So you go there, and you can see this is loading, and so then your this is the console that's presented to you, and you can see here, this is me, hooray. And currently I am operating in this cloud, or in this region, which is Northern Virginia. And if I click on that, you can see all the regions that Amazon has. So to make things a bit quicker, we're going to choose EU, which happens to be in Ireland. And you can see that I have 2 running instances there. And if I click on that, you can see that this is not as successful as I would like it to be, because one of them is giving me this little I'm not working sign. So if I wanted to launch an instance, then you go simply to launch that very clearly. And then the first thing that you're presented with, you can see here, is the Amazon partners. So these are basically the offerings from Amazon, and you can see the SUSE Linux Enterprise. There's the Amazon image themselves and other Linux distributions. What we want to look for is community AMIs, okay? And then you can see they have all kinds of community AMIs, and then ta-da, here is us, openSUSE. Of course, we know they can't spell, but they shall be forgiven for that. And we click on that, and lo and behold, there is openSUSE 13.1. And you will notice that there's a 64-bit image, simply for the reason that there is not really an advantage to have 32-bit and 64-bit images. It makes no sense. So I decided to just have 64-bit images because, 32-bit is really old and nobody uses it anymore. So you select that. And then once you're there, you get to see what kind of instance type you want to use. You can see there are micro instances. These are free. They can run for a certain period of time, and you get a certain amount of free time. The thing with this is, you get up to one virtual CPUs. This is the amount of memory you get. So you can see this is a whopping 0.63 gigabytes. Well, but it's free. And what else do you see here? You can see that the network performance basically sucks. Then these are other instances that you can choose. So we're just going to go for a general purpose, which is small. So general purpose, small instance type, 1 CPU, 1.7 gigabytes of memory. This is the storage that you get in addition to the root volume. So the root volumes are 10 gigabytes big. So if you need to install any application or whatever, you want to attach a second volume so that you have application storage, because the root volume is only 10 gigabytes. That's not going to go very far, okay? And then you go. So then we continue to configure. We're going to launch it into EC2 Classic. The availability zone, we don't really care. The shutdown behavior, you can see you can change that. You can say to stop the instance or to terminate it. Again, if you just stop the instance, then any changes that you made to the root volume are persistent, so the next time you boot it, those changes will be there. If you terminate the instance, then everything is lost, okay? That's also configurable, but by default, the images are set up so that everything goes away. Okay, and that was that. Then you could add storage if you want or not. So we're going to just continue on this, and you can see you get some helpful hints from Amazon. And you can see, so security groups means basically Amazon creates a firewall for you that sits in front of the instance that you're running. It's in front of the network, okay? And this firewall you configure through these security groups. Currently, it will create a new security group for me that's called Launch Wizard 2. And that security group will have port 22 open from any IP address. Okay, so when this is running, I can actually log in from here and not just from some specific machine. All right, so this is not really a demo about the Amazon Web Console, so I'm just gonna keep going. And since I'm the only one that's standing between you and the ends of the day, I'm better hurry. Okay, so what you do is you have to have a key pair. This is your SSH key pair that gets injected into the instance. So you have to have that. And of course, I won't have this on this machine, so I won't be able to log in, but I can show you that it's running. Okay, and then you acknowledge that you have to have that key pair, and then you launch the instance. And yes, if I would use my laptop for the demo, I could actually log in, but if I would do that, then you couldn't see anything because our recording boxes usually don't deal well with the video output that my laptop produces. So that's why I'm running on their machine. Okay, so then you get this wonderful message, and then you can view your instances and what you can see. So as you noticed previously, I had these two running. And now you can see there's one being launched. This is pending, and it's waiting for initialization. And this will spin for a little bit. And then this will change to running, and then eventually you will see the two green boxes. And again, if I had my SSH key on this machine, then I could SSH log into the machine. And that's really all I have. And so maybe now there are some questions, and if not, then you can be released. Okay. Questions? No?
Yeah. So, say if you wanted to customize your instance dynamically using some configuration management system, how would you go about doing that?
So the first thing you would, so if you use a plain openSUSE image, then you would have to start with this step. And then you can install Chef or Puppet, and then configure that to pull your stuff from a server. And once it's set up, the only key that you have to do is to just stop the instance instead of terminate it. While it's stopped, you're not accumulating any usage hours, so it's free, but it's there. And then when you restart it, your Chef or Puppet configuration is already there, and then you can just send whatever you need to send.
And if you wanted to do it by building your own image that has that support in?
So then you can go to the openSUSE build service. You can make a copy. You can branch the package. You can add Puppet or Chef into the Kiwi configuration file, and then you can just build it in your project, and then upload it to your account. And the way to get the images in there is in the Kiwi. So the Kiwi documentation actually has a step-by-step instructions on how you either create an S3-based image or an EBS-based image from the output of what you get from the build service. So that's all well documented.
That kind of brings me nicely on to another question, which is with the those Kiwi images that you had in the build service, I noticed all the sources for those, like the config.xml and the root tar gz, were all just stored directly in the OBS project. Is there a way of having those, say, in GitHub, and then using a source service to bring them in and still have OBS build those?
Yeah, we could do that, but so far I haven't seen the need to do that, because it's just as easy for somebody to just make copy pack in OBS, or do, branch the project in GitHub into their own account. So actually, if you do copy pack, then it's easier for you to keep the diff just in OBS. And if you have it in GitHub, then, I'm not really planning to make many changes to these images. Changes would only happen when 13.2 comes out and we have new package names for certain things. Those would really be the only changes that happen here in Cloud Images. So.
Yeah, I was thinking more of, like, if I wanted to fork that and then do something more complicated with it, and I wanted to track all those changes with Git and use the standard benefits of GitHub.
Yeah. We can certainly set something up in GitHub in the openSUSE project and stick it there and keep the sources there. It's fine with me. As I said, I'm not planning on touching it that often, and whether I keep it in GitHub or in OBS, it's the same to me.
Yeah, I was just wondering whether there's any fundamental limitation on the way that OBS builds images from projects containing Kiwi config that would prevent you from doing that using a source service.
Yeah, the fundamental difference is that for Kiwi you don't expect a tarball, so I still can't use the source service because it has to have the .kiwi file in as a plain file in the configuration. But I don't think the source service deals with that today.
You could use maybe tar SCM with disabled run mode, maybe.
Yeah, I don't know. I haven't looked into it, but theoretically it should be possible. And if not, it can still be in GitHub, and I can remember that. So it's not really that big of a deal. It can be done.
Okay.
It may not be automatic with source service, but it can still be done.
Mm-hmm.
So. Any other questions? And as you can see by now, this has been running, and which is this first instance here, and it has 2 checks. And now if we go and click on this, then you can see some information about that instance. And I can actually make this bigger. And so here's a public DNS entry that you can now use, and SSH-I, the path to my private key, and then root at that thing, and then you're in. So it's really easy. All right, thank you.